Hello, I'm Charles Neal, and welcome to my shop. We're going to start a series, we could probably call it Woodworking 101, kind of the basics. And it's totally free and for you. Now this is going to be on YouTube as well as our site. Again, totally free. You'll be able to download some SketchUps of the project that we're going to be building with dimensions. As well, you're going to be able to follow us along inch by inch and step by step as to how we build it. The project we're going to build is a pie safe. Well, what is a pie safe? Well, now this is just a plywood mock-up so that as we're doing it, we will have something to reference to. So when we're talking about pieces and parts and what we're doing, we know what we're looking at. A pie safe is one of the only true pieces of American furniture. Basically what it was a storage cabinet of some sort, and they used tin in it and they punched holes in it. The reason they did that is that, you know, in the olden days they didn't have refrigerators and, you know, all these things, and so insects and flies and things like that were a problem. So they could put the baked goods, thus the name pie safe, into the cabinet, and the tins in it being pierced allowed air circulation but wouldn't let the insects in. Well, that kind of brings up an interesting point about pie safes. Our shop is in Newmarket, Virginia. And Virginia, well, we just plumb famous for our pie safes. Now you can tell this has been around for a good while. With County, Virginia, punch tin, its influences. It was used in everything. Here's a door with punch tins. Kind of an early screen door version, if you will. They came in every kind of shape and size. And today, some of these original pie safes command huge fees. You find one. And one of the debates that I've always found kind of interesting about a pie safe is whether when you punch the hole, which basically you can use like a nail or just an awl, AWL, for punching it, is whether you put when you do that, the back of it gets pretty coarse. You know, it's tin. You do a nice motif or something on there. That thing looks like a cheese grater. So the question was does the rough side go in or out? Now the theory is if the holes are on the outside, an insect couldn't crawl up over the rough part of it and get in even the punch tin hole. We're going to put ours in, because I got to tell you what, you walk by and scrub that thing, and I tell you, it's like a cheese grater. So we don't want that. But in this series, what we're going to do, we're going to build the pie safe, as I've said. And we're going to do it, again, inch by inch. Now, I grew up with a pie safe. I was babysat by a lady who, they had an old plantation house, and on the back porch sat this pie safe. And it was pretty poor condition, but I would get in the shelves and play on it with my cars and whatever, and I remember this pie safe like it was yesterday. So we're going to build that one. It's what's called a 12-tin, because we've got 3 tins in the front, 3 in each side. 12-tin pie safe. Now, what would you use one for today? Anything. Nowadays, even with flat screen TVs and whatever, you could put a flat screen TV and electronics, whatever you want. But they're really cool and they're really neat. And we've built a fair amount of them. Customers and clients really like it. Now, those of you who are not familiar with us, we're a professional woodworking shop. I still make my living every day doing woodwork. So, but in this series, we're going to go back to the basics. We're going to be doing more. This is a very in-depth project using mortise and tenons and all the different ways that we do that. As well, we're going to go through and talk about selecting our wood, what woods do better where, why you want them. Now, we're going to be doing 3 different pie safes. We're going to do a red oak. We're going to do one out of poplar. And then we're going to do one out of junk. Good wood, but pretty ugly, because we're going to paint it. And we're going to take the painted one and make it look like, well, how do you say painted? It's painted. Yeah. Same as a pine nut. So we're going to paint one. And we're going to make it look like it's 200 years old and all that. The poplar one, based on your choice, we're either going to make it look like walnut or we're going to make it look like cherry. Whatever you want. Cherry being a natural cherry. Don't have to get real dark. Because we want you to experience the finishing process. Now, just so you know, I've been doing woodworking professionally now for 30-some years. And I've been finishing since I was 13. And that was a long time ago. All right. So, this is what we're going to do. Now, we're going to try to get it up in like 30-minute increments every week or two. And so you follow along. Again, you can go to our website. We have our own forum. And we'll have on there where you can ask questions, discuss it. You can email me. The object of the game with this is for you to learn woodworking. And hopefully you can get something out of this. So I tell you what, let's get to building. Okay, let's talk about wood selection. You know, that's an extremely important part of any project. If we look at this pie safe, where we're going to start is with the corner post. In our SketchUp model, we're calling for these to be 1 3/4. Now that means we got to start with 8-quarter lumber. For those who don't understand it, that's a lumber mill lingo for 2 inches. There's 4 quarter of an inches in each inch, so 8 quarters, 2 inches. Now, what you'll see when you start looking at wood, and oak is a good example. If you look up here, you see all the grain running this way. We refer to that as cathedral grain. But when you get into a post, you want something more straight grain. Let's talk about that a minute. This is a piece of what is called rift sawn, R-I-F-F. Rift sawn lumber. If you look at the end of this, let me see. Let me do a little quick chop on it so you can see it better. If you look at this very carefully, the first thing you're going let's take a look. If you look at the end of this, you're going to see the grain in this is running on an angle. Okay? If you have what is called quarter sawn lumber, that grain is going to be running vertical. This is the most stable lumber. The reason being is that it's like when you're building a house or something and you take a 2x4 or 2x8 or 2x10 when you're doing floors or whatever, and it's the same as turning it on its side. You have all that strength from the width. The other thing is that this does not expand and contract as much. Much more stable. If you look at the end of this piece of poplar, the first thing you're going to notice is this is a wider board. If you look in here, you're going to see these rings. That's your cathedral grain. But look very close. See it? We've got that rift sawn going on out here. And oftentimes you'll see it, it's going to be quarter sawn. In this case, this is some soft maple. And it's just kind of squirrely in the grain, but I've still kind of got grain running this way. In here, I'm running this way. Now the pie safes we're going to build, we're going to take this piece of soft maple. It's what's called ambrosia. It's got wormholes and streaks, and it's just nasty. Although it can be very pretty in a standalone application. But for this, we're going to paint it. So we don't really care what the wood looks like as long as it's nice and solid. And we can get the proper stuff we want. Now at this point, you're going to notice we've not planed anything for the post. Here's why. Particularly this piece of poplar. Even though our posts call for 1 3/4, in reality, I want them as thick as I can get them. But you see the cup in this? If I plane that and I'm able to get most of that cup out, well, look how much I've reduced my, I've got to take this corner down, then I'm going to have to take the center of this down, and I just lost all my thickness. On the other hand, if I look at it from that perspective, and here, if I can get this cut in two, then I can saw it and get a much straighter and much thicker post. It's always best to work your wood in as smaller pieces as is practical. Practical means not cut to size. When you're building a project, rough everything out. But in this case, I think this piece we're doing 2 pie safes, 3 actually, and our pie safe, wherever my glasses are at, is about 58.5 for this one, and it's going to be about 62 or 63 inches tall for the one that's going to get the drawers. So I'm roughed out at 64 inches and 62, 63 inches. Always cut them long. And in just a second, you're going to see another reason to cut them long. Now what we have to do is we have to, in order to cut this, I was looking for my glasses. Here they are in my hand. Y'all didn't tell me. Okay, you'll have that around here. Here's what we're going to do. First thing we got to do in order to rip this on the table saw is we got to get a straight edge. If you have a joiner, you obviously know, or hopefully know what to do. So we're going to take a look at using a joiner. Then we're going to take a look at another little technique for those of you who don't have a joiner. When you buy wood from the lumber mill, you're going to find, you got to plane it, it's rough sawn. Now this has just been what we call a hit and miss. We just barely skimmed it so we could show you. And when this wood is dried, just like the piece of poplar we just looked at, it cupped. You pull the moisture out, the wood goes where it wants. And that's why you can't buy wood from a sawmill in perfect dimensions. It comes off trees. Now the first thing you notice on this piece of rift sawn 8/4 oak is we've got a pretty straight line here. Again, Rift sawn and quarter sawn material is the most stable. Quarter sawn is even a little more stable than rift sawn, but they're both very stable. On the other hand, and we really don't have anything here that's really bad, but almost every piece of wood, let me see if we can flip this up here. Every piece of wood will have what is called a wane. And what a wane is that the board is going to be in a bow over the length of the edge. If you talk to a contractor who builds houses like we talked about, they're going to sight those floor joists and whatever, and they're going to look at it, and they're going to see which way that wane's going. It's called the crown. And you want to put the crown up, because when they do that and the pressure and everything gets done, the pressure pushes it down, but the wood itself is pushing back. But in furniture, that's a different animal. The problem you have is when you've got this, and again, this isn't bad. I've seen them far worse. What you want to work on, if you've got that crown, and it's bowed like this, and you try to go across a joiner, what's going to happen is it's going to go, and you can just keep jointing forever until you don't have a board left, and you'll still have a, and those, they're not real good. So here, what's the answer? Well, what you do is you want to go point to point, meaning in this case, this point and that point's a little higher. So what we're going to do is we're going to knock them off and get us a straight line. Now there's a ton of videos out here and a ton of information on setting up your joiner. But very quickly, the way it works is, this is an out feed table, you have an in feed table, and to set it up, you want to bring the in feed table, the in feed table level with the out feed table. Your gauge set at 0, and make sure the tips of your knives are touching a straight edge that's across it. That gives you a complete level surface. Then, as you lower, when you start working, as you lower the in feed table, it's going to take wood off of the front edge, which as it comes over to the out feed table, that keeps it straight and allows you to straighten your board. I see a lot of guys talk about, well, gee, I face joint it, meaning you're face joining a piece of wood, which we'll get to later. And it's not the same thickness. Joiners are not made for thicknessing wood. They are designed and made purely for straightening wood. That's their intent. There's a lot of other things we can do with them, but its intent is to give you a straight surface and a parallel surface. But right now, all we need is a straight surface we can cut from. Now just one quick pass across there, and the first thing you notice here is I'm hitting all the way down. Not perfect, but I've got an indexable surface from which to saw from. But again, what if you don't have a joiner? Let's go table saw. All right, this piece of poplar. The first thing you notice, if you can see this gap, we're about 1/4 of an inch in the center. I've seen them 1/2 inch, 3/4 of an inch. I've seen them 1 inch. But again, notice we're on point to point. That's our indexable surface. Now what can we do? Here's a little jig that we do among many. And what this is, you can see, it's basically an offset T. And it's straight. Made out of some plywood and a piece of scrap maple. And it's got two different heights on it. Now here's what I'm going to do. I'm going to set this up here. Okay, and you notice the maple, we've got some holes drilled in it. So what this does is this sets up here, and this creates a straight edge. Now I've got a little piece of MDF underneath here to shim it up because this 8/4 is a little tall. And I'm going to clamp it to my fence. Now I told you we always leave our material long. Let me make sure I'm good here. We're good. Okay, I'm going to take this piece of MDF because I'm long and it's straight, and I'm going to set it to make a straight edge. And I'm going to screw it on. Now what I'm after is I'm going to screw it on just on the end so I can remove it and it'll be cut away when we go to do our post. Now again, we're just roughing in, and all we're after is an indexable surface, meaning a surface that is straight that we can cut from. We can index off the fence. Now we just created a joiner. Now the piece of 8/4 is sitting underneath the sled. So now we have a straight line here and we have a straight line here. Now obviously my fence is out of, my fence tape is not going to work on this. All right. Now I'm running a 40-tooth carbide blade. That's a little bit light for this, but it'll do just fine. I just don't want to go through as fast. And you notice we have a splitter. Those are very important. I would say on a table saw, that splitter is probably one of the most important safety features you can have. Now, I can get rid of all of this because I have a straight line. I have something I can index off of. Now for those of you who have a small bench top, table saw or whatever, you really want to fix you up a nice outfeed table. You don't want to be working heavy 8-quarter table that can go off the end of the saw and fall. That's dangerous. The other thing is, the longer the fence, the better. So even if you rig up something like this to make your fence longer, that's a good idea. You could also take the same fence, clamp it on this way, and you have an extended fence. Working long material, really, really good idea. Okay, what I'm about to show you is how not to do something. Now let me explain. There's two things. First of all, I'm telling you to use a long fence. The long fence is used to get a straight edge on a long board. It's used for edging, not for the ripping. I want to clear that up. Here's why. You take a long piece of wood like this, especially if you got something that's got a knot or whatever in it, these woods have internal stress. And the bigger and thicker the wood, the worse. So what happens is when you go to rip it, that wood can try to spread, open up. That's where a splitter or a riving knife is used to keep that wood from being able to pinch back on the blade. Another area this happens is when you try to cut a piece of cupped wood. Got that big crown in it. In either case, what happens, and you're going to see this. Now I'm going to explain this again. I've been running a table saw for 30 some odd years. I know exactly what's going to happen with this piece of wood. Exactly. And I'm fully prepared for it. But the reason I'm going to show it to you is so you understand and you don't take a chance on doing it. We've got a piece of wood that's cupped. When we saw it with the crown up, the wood falls, pinches the blade. That can cause a kickback. By the same token, if we flip it, if it's a thin piece, it's not so bad. But if we flip it, when we cut it, it's going to do basically the same thing. Not as bad. But it can pinch on you. And when it pinches, it can kick back. So the point of these two exercises is very simple. One, to show you how not to do it and to exaggerate what can happen. Again, I'm fully prepared for it. But don't do it. And I'm going to show you why. And the other thing is, again, the long fence is used for straight lining. In the case of the pie safe, once we have our post roughed out, then to be able to use a long fence as an index, a long index point, is a good thing. The reason being is we've pretty much removed the stress. That's why we want to cut everything to oversize. Because then, if it's got any kind of a bow or whatever in it, if you have a joiner, obviously join it straight and go again. But if you don't, having this long straight edge that can run against makes for a much straighter cut. Just does. Wanted to clear that up and make sure everybody understands. Let's get on with the build. Okay. Now what I have is like I said, I have this straight edge. Now I took a good bit off because I had some bark down here, but I have an indexable surface that I can saw from. But I've still got this big bow in this big cup. If I saw this with it in this position, crown up, what's going to happen as it goes through that saw, when it's complete cut, it's going to drop. It's going to try to pinch. So the way I want to saw it is going to be like this. So that when it goes through the saw and it releases, it's going to try to fall away from the blade instead of fall into the blade. Okay. Since this is 2-inch thick material, and actually it's about 2 1/8. Most of your good mills, if they're sawing 8/4, they're going to saw it an extra 1/16 of an inch, 1/8 of an inch. A piece of 8/4 material is designed to give you 1 3/4 inches. That's its finished goal. A piece of 4/4 is designed to give you a 3/4. If you got nice stock, you can get 7/8. If you really want 7/8, you probably need to look at a 5/4 stock. And on it goes. All right. Now, I know that when I break this open, this thing is subject to more movement. So I'm going to cut, and I have a total width here of 11 inches. So what I'm going to do is I'm going to cut this to 5 1/4. I'm not going to get enough scrap off of this to make any difference. So what I want to do is make sure I've got enough to get the post. So again, we're rough cutting. So I'm going to go to 5 1/2. What did I tell you? I'm talking and ain't listening. 5 1/4. And I'm going to cut it. Now, this is where that splitter is important. And where this, right now what it's doing is it's going down, it's trying to lay down. And again, it's trying to pinch a little bit on the bottom. That's where this splitter can help. Now, I'm not so bad, and it's only going to occur at the end. But I want to stop the saw, and I want to show you that. Now, the other thing we've got is that we're going through here, and you see it. It's because of that hump in the bottom, it's trying to rock. Okay, what would be a good alternative to this? Maybe a quick rip down the bandsaw, or a jigsaw, or a skill saw. Something to get it in half. Okay, we've got the rest of them. I'm going to join them, and in our next episode, we're going to come back and cut the post.